All right, so we'll go ahead and start reviewing for what will be on exam number 2. All right, problem number 1 does says which diagram represents not a function and explain why. So in this case here, you're going to be given like 3 different mappings, A, B, and C. And you want to choose which diagram is classified as not being a function and explain why it's not a function. All right, so in this case, it would be mapping A, B, or C. Is C. And the reason for that is, okay, and you do have to give the reason why it's not a function. Okay. Now, if you recall, when we're dealing with a function back in section 2.1, you cannot have an x value paired with 2 different y values. So the one on the left represents your x values, the one on the right is your y values, and that's for each one of these mappings. And as you can see, that -4 is paired with 2 different y values, 1 and 3. So you can say something like this. For the reason -4 is paired with these 2 values, 1 and 3. So pretty much you can give a reasoning something like this. Okay. Are there any questions about problem number 1? Okay, problem number 2 is using a vertical line test to determine if the graph below represents a function. So I'm going to go ahead and draw the graph that's similar to the one on the review sheet. So let's say we had a graph that looks like this. And I want to know or determine if this graph represents a function using the vertical line test as indicated in the directions. All right, so would this graph represent a function? No, it wouldn't. And here's why. Well, if I draw that vertical line going through the graph, that vertical line crosses this graph at 2 different places. So that means that this graph itself is not a function. Okay. All right. Are there any questions about problem number 2? Determining whether a graph is a function by using a vertical line test. All right, now problem number 3. Here we got the function f of x is equal to 3x cubed plus 5x squared. And here I want to find f of 4. So we want to know what the value of that function is when x is equal to 4. Okay. So pretty much all we need to do there is just to replace the x in each x I'm going to replace it with the negative. Actually, it's -4. Where did I get that? Okay. I'm just going to say negative sign. So we're finding f of -4. So that means we substitute the x with -4. So it'll be 3 times, and I'll just say here f of -4 is equal to 3 times. That x will be replaced with -4, and that's cube, plus 5 times x, which is negative 4, and that's going to be squared. And then we just simplify from here. Let's see, I'm going to bring down the 3, but when I cube a negative, that's going to be a negative. So that means that negative 4, and we cube it, will have to be negative 64. And then plus 5 times. If I square negative, that's going to be positive. So negative 4 squared would be negative 4 times negative 4, or 16. And then what's 3 times negative 64? Okay, negative 192 plus what's 5 times 16? That'd be 80. And then negative 192 plus 80. Negative 192 plus 80. Yeah. Negative 112. So the value of that function when x is equal to negative 4 would be negative 112. Are there any questions about problem number 3? All right, number 4. Now this time we got g of x is equal to x squared plus 2x plus 3. And I want to evaluate g of x plus 5. So here we're not looking for a numerical value, we're looking for the expression after replacing each x with x plus 5. So that means that this x will be replaced with the x plus 5, and that's going to be squared plus 2 times. The x will be replaced with x plus 5, and then plus 3. And from here we go ahead and simplify. Well, that x plus 5 quantity square, if you want to, you can do this as off to the side. Since x plus 5 is used as a factor twice, I'm going to go ahead and write that as x plus 5 times x plus 5. And use the full method. So in this case here, that means first term times the first term, x times x will be x squared. The outer would be x times the plus 5 will be plus 5x. The inside would be 5 times x will be plus 5x. And then plus the last term times the last term, 5 times 5. That'd be 25. And then combine like terms here, you got x squared. 5x and 5x will be 10x plus 25. So here x squared, x plus 5 quantity squared would be that x squared plus 10x plus 25. Now for the 2 times the quantity x plus 5, I'll use a distributive property. 2 times x would be a plus 2x, and 2 times a plus 5 would be plus 10, and then bring down the plus 3. Now, let's clean all this up by combining like terms. Bring down that x squared. Let's see, 10x plus 2x is how much? 12x. Now, 25 plus 10 plus 3 is how much? Be 38. So, the expression after replacing the x with x plus 5 in the g of x function would be x squared plus 12x plus 38. Okay. Are there any questions about problem number 4? Now, in number 5, A, B, and C, you're going to use the graph that's given to you to determine the open intervals on which the function is increasing, if any, the open intervals on which the function is decreasing, if any, and the open intervals on which the function is constant, if any. So let me just write down A, B, and C. All right, so let me bring the graph on the screen, and then I'm going to use a piece of paper to cover the graph and move it from left to right. Because when we're finding the intervals in which that function is decreasing, we always use the x values, and also we read along the x-axis, and our intervals are always going to be open intervals. That means we only use parentheses. So from left to right, well, that arrow tells me it goes on forever and ever and ever. So that means our x on the left side will be from negative infinity. Now you can see that it's going to be increasing, and it stops increasing at what x value? Negative 4. Take a look. Negative 4. Okay. So from negative infinity up to negative 4, the graph of that function is increasing. So it's increasing on this interval, negative infinity to negative 4. And then after that, after negative 4, as you can see, it's decreasing, and it stops decreasing at what x value? Negative 3. So between negative 4 and negative 3, the graph of that function is decreasing. So let me add to part B. Decreasing on the interval from negative 4 to negative 3. Okay. So let's see, after negative 3, it increases again. Up to what x value? Negative 2. So between negative 3 and negative 2, the graph of that function increases. And then after negative 2, pretty much you can see that it's going to be decreasing indefinitely to the right. So from negative 2 on to infinity is where the graph of that function decreases. All right. Now as for constant, there's no straight line anywhere, so the answer for that would be none. So here is increasing on these intervals, negative infinity to negative 4 and negative 3 to negative 2, decreasing on the intervals from negative 4 to negative 3 and from negative 2 to infinity, constant nowhere. Okay. Are there any questions about problem number 5? All right, number 6 is another graph. This time, we're dealing with relative maximum and relative minimum. So here you're given the graph of this function. And we want to use this graph. Let me shut this light off. And we're going to be using this graph to identify or find the following. In part A, we're going to find the numbers, if any, at which f has a relative maximum. And then what are these relative maxima? And B is going to be the numbers, if any, at which f has a relative minimum. And what are their relative minimum? Let's see, let's start with the relative maximum. That's going to be the highest point on this graph. The highest point on this graph, which is right here. That's the relative maximum. What x value does this relative maximum occur? Let's look. -1. This might be hard to see, but at -1, that's where the relative maximum occurs. So here we can say here that the relative maximum occurs at x equal -1. Now let's find out what that relative maximum is. That's going to be the y value. So what's the y value for this highest point on that graph? 2. So your relative maximum is 2. Keep in mind your relative maximum and minimum will always be the y value. Where it occurs will be the x value. And in this case, x equals -1. Now for part B is the relative minimum. Okay. So going back to this graph here, notice we have 2 relative minimum or minima. They occur at what x values? -2 and 0. So we got 2 places where this relative minima occur. At x equals -2 and x equals 0. And based on this graph, what is the relative minima? -2, that's the y value here. The lowest y value here for that graph is at -2. So here the relative maximum occurs at x equals -2 and at x equals 0. Your relative minimum is the y value -2. Okay, are there any questions about problem number 6? All right, number 7, here you're given a piecewise function. That's f of x is equal to -2x plus 3 only if x is less than or equal to 4, 3x if x is between or greater than -4 and less than or equal to 7, and 5 if x is greater than 7. Okay. And we're going to use this piecewise function to evaluate, let's say, f of 4. So my x is going to be 4, so which one do I need to use? The first, the second, or the third? The first one, because the x value that I'm dealing with does equal to 4. It's less than or equal to 4. So I use -2x plus 3. So I'm going to substitute the x with 4. So it'll be -2 times 4 plus 3. Now what's negative 2 times 4? Negative 8. And negative 8 plus 3 is negative 5. So the value of that function, of that piecewise function, to be specific, when x is equal to 4, would be negative 5. Okay. Are there any questions about just the f of 4? Now what about f of 234? How much? We will use the third one, because 234, that's greater than 7, so the only value for that is just a 5. So the value of that function when x is 234 ends up being 5. Okay. Are there any questions about problem number 7? All right, problem number 8 is determining whether a function is even or odd or neither. So here we got f of x is equal to 3x cubed minus 6x plus 1. Now the way I work that problem out, you have to replace every x in that function with negative x. That will help you determine whether the function is even or odd or neither. And the way we do that is, well, if you get the original function that you started off with, then that means that your function is even. If every single term changes to the opposite sign, then that means that function is going to be odd. Otherwise, it's neither. So here I'm going to replace each x with negative x. So here I'm going to have 3 times negative x, and that's cube, minus 6 times negative x, plus 1. Now, a negative to an odd power will always be negative. Then I'm going to bring down the 3. That x will be to the third power. So I have negative 3x cubed minus 6 times the negative x will make that a plus 6x. And then I'll bring down the plus 1. Now compare what f of negative x is to what f of x is. Is it even? No, because I didn't get the original function that I started off with. What about odd? No. Take a look. The first term and the second term are the only 2 terms that change to the opposite sign. That plus 1 remain the same. For it to be odd, every single term must change to the opposite sign. So this function is neither odd nor even. Okay. Are there any questions about problem number 8? Just determining whether a function is even or odd or neither. All right, problems 9 and 10 deal with finding their domain. And you're to give your answer, your domain, in interval notation. So let's say we have this function f of x equals to 2x cubed plus 9x squared plus 7x minus 4. That's divided by x squared plus 4x minus 12. And here I want to find the domain of this function here. In this case, what type of function do I have here? A rational function. Those have a numerator and a denominator. I do have variables in the denominator. So what I need to do here is take that denominator, which is x squared plus 4x minus 12. I'm going to set that to be equal to 0 because I want to find out what values of x that would give me a 0 in the denominator. Now in this case here I do have a quadratic equation. And I believe I can take that x squared plus 4x minus 12 and factor that into two binomials. So x squared breaks up as x times x. The middle term is a plus, the last term is a minus, so one has to be plus, the other one has to be minus. And I need factors of 12 that will give me 4x as a middle term. Let's use 6 and 2. Now, the larger of the two factors takes this sign of the middle term. The 6 is the larger of the two, so the 6 has to be a plus 6, the 2 has to be minus 2. So here I got x plus 6 times x minus 2 equal to 0. And then I'm going to set each binomial factor equal to 0 and solve. So that means I get x plus 6 is equal to 0, or x minus 2 is equal to 0. Now for the x plus 6 equal to 0, what must x have to be equal to? Negative 6. And then for x minus 2 equals 0, what must x have to be equal to? 2. So those are the two values of x that will make the denominator 0. X equal negative 6 or x equals 2. Now, the interval notation for this, and this is not necessary that you draw a number line, but if this helps, feel free to do so. So let's say here's 0 here. 2 is to the right of 6 and negative 6 to the left of 0. Or 2 is to the right of 0. Now negative 6 and 2, we know we're going to get a 0 in the denominator. Those will have parentheses there. Any x value less than negative 6 would work for this rational function. Any x value in between negative 6 and 2 would work. And any x value to the right of 2 would work. So, the domain in interval notation, if we go from left to right, it will be from negative infinity up to negative 6, or from negative 6 to 2, or from 2 to infinity. That would be the interval notation for the domain of this rational function. All right. Any questions about problem number 9? All right, number 10. Here we got f of x is equal to the square root of 84 minus 6x. Now what type of function do I have here? This time it's a radical function, but it does have an even index with it. So that means here I take what's underneath the square root, which is that 84 minus 6x. We set that to be greater than or equal to 0 because we cannot take the square root of a negative number and obtain a real number from it because we're looking for the set of all real numbers for our domain. Now let's get the x by itself. So how would I do that? How would I get x by itself to begin with? Subtract 84 first. That's the first thing we have to do, subtract 84 on both sides. So now we got negative 6x is greater than or equal to negative 84. And then what's next? Divide by negative 6. But what's going to happen to this greater than or equal to symbol? We're going to flip it to less than or equal to. So x is less than or equal to what? 14. Okay. So that would be the solution set. But let's say interval notation, because on your exam you will be required to give your solution set for the domain in interval notation. Okay. Now for 14, do I need a bracket or parentheses? Bracket. And it says less than, so I know I need a right parentheses. That less than or equal to symbol points to the left. That means we shade everything to the left of 14. So here the domain, if you were to give this an interval notation from left to right, it would be from negative infinity up to 14, with the bracket to indicate that 14 is included in that solution set. All right. Are there any questions about problem number 10? All right, in problem number 11 is the combining of two functions, combinations of functions. Here we got f of x equals to 2x minus 25 and g of x equal to 3x plus 7. And we're going to perform the algebra of functions here. So in this case here we got f of x equals 2x minus 25. And let's see, g of x is equal to 3x plus 7. And in part A, they ask for the sum of the two functions f plus g of x. So in this case here, we're looking for f of x plus g of x. F of x plus g of x. So pretty much f of x is at 2x minus 25. Then plus g of x is 3x plus 7. So all we're doing there is just combining like terms. So that means if I do 2x plus 3x, that's going to give me 5x. And then minus 25 plus 7 would give me how much? Minus 18. And here we're done with that problem. So in this case here, the sum of the two functions would be 5x minus 18. Okay. Are there any questions about part A? In this case here, part B, we got f minus g of x. All right, so f minus g of x, that's just f of x minus g of x. And here, f of x, that's 2x minus 25, minus the g of x, we need to put 3x plus 7 in parentheses. Keep in mind, we're subtracting the entire g of x function from what f of x is. And I see many students leave off the parentheses. You're subtracting the entire g of x function from f of x. So that 3x plus 7 has to be in parentheses. Now let's simplify this. That minus sign will make the 3x minus 3x, and then the minus sign makes a plus 7 minus 7. And then we combine like terms here. 2x minus 3x is negative x, and then minus 25 minus 7 would be a minus 32. So here, negative x minus 32 represents the difference of the two functions f and g. Are there any questions about part B? All right, part C is the product of the two functions here. Now I know in the study sheet it does have f and the time sign with g. But here I'm just going to say fg of x, which does represent f of x times g of x. So f of x is 2x minus 25 times g of x is 3x plus 7. Well, we're multiplying two binomials. That means we can use the FOIL method on this. So here we got first term times the first term, 2x times 3x, which is 6x squared. The outer will be 2x times the plus 7, which is plus 14x. The inner will be minus 25 times 3x, which is minus 75x. And then finally, minus 25 times plus 7. How much? We get negative minus 175. And now we can combine like terms here. Plus 14x minus 75x is how much? Negative 61x. And then bring down the minus 175. So that's the product of f and g of x will be 6x squared minus 61x minus 175. Any questions about part C? And then part D is f divided by g of x. That's the quotient. So here we got f of x divided by g of x. So f of x is at 2x minus 25 divided by the g of x, which is 3x plus 7. And that would be as far as I would go with that problem, because there's no common factors that I can divide out in this case. So that's the quotient of f and g of the function of x. Okay. Are there any questions about problem number 11? Okay. Make sure that you do try to get some points here, because I have seen papers where this problem right here, where you're finding the sum, the difference, the product, and the quotient, there's some students that leave that question blank. Okay. Now on to number 12. Here's another one that I see students leave blank as well. The composition of the two functions f and g. We're given that f of x is equal to 5x minus 23 and g of x is equal to 4x plus 1. So in part A, you're going to find the composition of f with g of x and the composition of g with f of x. So number 12, I'll just write this out. F of x is equal to 5x minus 23. And g of x is equal to 4x plus 1. And we're looking for the composition of f with g of x. Which simply means f of g of x. Now the inside function is g of x, and g of x is equal to 4x plus 1. So I'm going to bring this f down and replace the g of x with 4x plus 1. That means we're evaluating f of 4x plus 1. Now, of course, your f of x is given as it being equal to 5x minus 23. So every x in this f of x function, we're going to replace it with what g of x is. So this x in the f of x notation will be replaced with the g of x. That's the 4x plus 1. And in 5x minus 23, the x there will be replaced with the g of x, 4x plus 1. Then we simplify the right-hand side. If I distribute the 5 over the 4x plus 1, what would I get? 20x plus 5. Bring down that minus 23. Combine like terms, I have 20x plus 5 minus 23 is how much? Negative 18. So that is the composition of f with g of x. It's equal to 20x minus 18. Okay. Are there any questions about part A? All right, the composition of g with f of x is part B. In this case here, this is just g of f of x. So now the inside function is f of x. And f of x is that 5x minus 23. So I replace that f of x with what is equal to 5x minus 23. So I'm going to be evaluating g of 5x minus 23. And here g of x equals to that 4x plus 1. So for every x in the g of x function, I'm going to replace it with what f of x is. So now that x will be, in the g of x notation, will be substituted with f of x, and that's the 5x minus 23. And this x will be substituted with 5x minus 23, which is what f of x is. Okay, so now let's simplify the right-hand side. If I distribute the 4 over the 5x minus 23, what would I get? 20x minus 92. Okay, and then 20x minus 92 plus 1 would be negative 91. So the composition of g with f of x, that'd be 20x minus 91. Okay. Are there any questions about problem number 12? All right. Number 13. here we're decomposing this function, because you're told that f of g of x or the composition of f with g of x, where g of x is the inside function, that's going to be 5 divided by x squared minus 3x plus 6. And that's raised to the 6th power. And we want to determine the functions f and g, f of x and g of x, such that we get this. We want to know what f of x started off as and what g of x is. Now, of course, your g of x is your inside function. And notice in this case here, we have a numerator and a denominator. So if you want to, you can take that denominator, let that be g of x. That's the x squared minus 3x plus 6. That quantity is to the 6th power. Now, to find out what f of x is, since this whole thing in the denominator was substituted for x in the f of x function, that means f of x had to start off as 5 over x. Okay. Any questions on number 13? Now, with this one, there's a couple of ways you could have written this for f of x and g of x. Oops. Let me. You could have let what's inside the parentheses be g of x. Okay? What's inside the parentheses could be g of x, which will be that x squared minus 3x plus 6. And then, since that x squared minus 3x plus 6 was put in place of x, f of x could be 5 divided by x to the 6th power. Okay. So it could be this one or this one. And if you had something like f of g of x equal to the square root or something, then what's underneath the radical will be your g of x, and then f of x will start off as a square root of x. You might see something like that on your second exam. All right, questions on number 13. All right, number 14 is finding the inverse of the function. All right, in this case here, we've got f of x equal to 9x plus 23. And here I want to find out what f inverse of x will be. And of course, that 4-step procedure is what we use to find the inverse of the function. And by the way, that function is already 1-to-1. So from here, we can go ahead and use that 4-step procedure. First of all, we substitute our f of x notation with y. Excuse me. So here we got y is equal to 9x plus 23. Substitute the f of x notation with a y. Now we interchange x and y. That's going to be step number 2. So this will be x is equal to 9y plus 23. That means that y becomes your x and every x becomes y. And then next we solve this equation for y. So we first subtract 23 on both sides. That would mean x minus 23 equals 9y. And then to get y by itself, we need to divide both sides of this equation by 9. So that means that y is equal to, here we got x minus 23, whole thing is divided by 9. And then the final step would be to replace that y with this notation, f inverse of x. So that means f inverse of x would be x minus 23, the whole thing divided by 9. Okay. Are there any questions about problem number 14? And finally, problem number 15 is using the horizontal line test to determine if the graph below has an inverse. So here, if I draw that graph, so when we draw a horizontal line test, a horizontal line, that horizontal line has to cross the graph at only one place for it to have an inverse function. So would this have an inverse function? It would. It's only crossing the graph at only one place. So this has an inverse function. Okay. All right, are there any questions about problem number 15?